Hi everyone, I am Reshma C, Assistant Professor, Department of Civil Engineering, SNIT, Adur. Today, we are going to deal with a topic that comes in the subject CE 304 Design of Concrete Structures 2. Today's topic for discussion is classification and method of prestressing. This topic comes under 6th module of DCS 2 for 6th semester KTU Civil Engineering branch. Before moving on to today's topic, let's have a recap of previous classes. In the previous classes, we had an introduction about pre-stressed concrete. We studied the difference between ordinary concrete and pre-stressed concrete. We understood about the concept of pre-stressing and also about the materials used in pre-stressed concrete members. So pre-stressed concrete is nothing but the concrete in which an initial pre-stress is given to counteract the stresses resulting from external loads. Moving on to our topic, types of pre-stressing. Based on the source of pre-stressing or the method by which pre-stressing is generated, there are 4 types. First one is hydraulic pre-stressing. In this type, hydraulic jack is used for tensioning of tendons. Second one is the mechanical pre-stressing. In this type, pre-stressing is done with the help of machines. Third one is thermoelectric pre-stressing. In this type, steel wires are electrically heated and anchored before placing of concrete. And the last one is chemical pre-stressing or self-stressing, in which some special type of cement like the expanding cement, which expands up to 3 to 4% is used. When concrete expands, the tendons also expand and tensile pre-stress is introduced in tendons. These tensile stresses are transferred to concrete in the form of compressive stresses. Next is the classification of pre-stressed concrete members based on its design and construction. First one is internal and external pre-stressing. In external pre-stressing, the pre-stressing is achieved by elements outside the concrete. That is, in this type, instead of providing a tendon from which pre-stress can be applied, the necessary pre-stressing force is applied to the member by compressing it by jacking against the abutments or whatever. Now, in internal pre-stressing, the pre-stressing is achieved by elements located inside the concrete member, that is the tendon or the steel wire. So the pre-stressing force is applied to steel, which induces the internal compressive stresses in concrete. This internal pre-stressing is of 2 types, pre-tensioning and post-tensioning, which we will discuss later. Next is linear and circular pre-stressing. In linear pre-stressing, as in the case of beams, slabs, columns, piles, etc., pre-stressing is applied in straight alignment and this is called linear pre-stressing. Now, circular pre-stressing. Cylindrical structures like silos, circular tanks, pipes, etc., hoop tension is generated due to the applied loads. Therefore, pre-hoop compression is to be applied by circular pre-stressing. Here, the pre-stressing tendons are wound around in circles and then pre-stressed. Next is partial or full prestressing. If the prestressing is such that there are no tensile stresses in it under the working load, then that concrete is said to be fully prestressed. And if there is some tensile stress produced under the working load, then it is called partially prestressed. Next, we are going to discuss about pre-tensioning and post-tensioning, which comes under internal pre-stressing, and this is one of the very important topics in this session. Moving on to pre-tensioning, the method of pre-tensioning and the transferring of pre-stress was shown in the introduction class. Let's have a look into it once again. For pre-tensioning, first and foremost, there should be a pre-stressing bed. Then the mold is to be placed in position within the pre-stressing bed. Then the high tensile steel is threaded through the mold at required level, and the steel is then tensioned to the required pre-stress using jacks and anchored. This is shown in A part of first figure, applying tension to tendons. Afterwards, concrete is poured in the mold and allowed to set. This is shown in B part of first figure, casting of concrete. When the concrete is set and attained sufficient strength, the tendons are cut off and the pre-stress is transferred to concrete through bond action between concrete and steel. This is shown in C part. Advantages of pre-tensioning are: the structural element to be pre-stressed is small and can be easily transported. More number of similar elements can be produced at the same time, such as railway sleepers, electric posts, etc. Costly anchorage units are not required. And the disadvantages include the following: pre-stressing force cannot be transferred to concrete member immediately after casting. The concrete has to well set and attain its strength. Pre-stressing can be done only where there is a pre-stressing bed. Moreover, the bond properties between steel and concrete should be adequate. Moving on to post-tensioning. In post-tensioning, the concrete units are first cast and they are provided with ducts or grooves to accommodate the pre-stressing tendons. And these ducts are provided with metal sheeting ducts or the cable ducts. The ducts may be arranged in any shape to get the required cable profile. This is shown in A part, casting of concrete in figure. After the concrete has attained sufficient strength, the pre-stressing cables are threaded through the ducts and they are tensioned using hydraulic jacks, which is depicted in B part of figure, tensioning of tendons using jack. After applying the required pre-stressing force, the tendons are anchored at the ends by means of special anchoring systems provided at the ends. The force is transmitted through the external anchorage system at the ends of structural concrete element. This is depicted in C part of the figure. Additional reinforcements has to be provided to prevent local splitting and failure by shear at the end, as excessive bearing stresses will be produced at the end of members due to anchoring devices. Advantages of post-tensioning includes the following. Post-tensioning is adopted for long and heavy structural elements. The labor at site is not costly. The ducts may be arranged to any shape to get the required cable profile. And finally, the desired pre-stressing force can be quickly achieved. Disadvantages of post-tensioning includes the following. All the wires are stretched together, hence stresses developed in the wires may not be uniform. The maximum pre-stressing force that can be applied to a cable is from 350 kN to 500 kN. this may not be sufficient. And the jack used for post tensioning is very heavy and difficult to handle. So now we learned about pre-tensioning and post-tensioning, which are two types that comes under the internal pre-stressing. Now let's see the differences between pre-tensioning and post-tensioning. First and foremost, in pre-tensioning, the tendons are tensioned before the concrete is cast, whereas in post-tensioning, the tendons are tensioned only after the concrete has attained its sufficient strength. Pre-tensioning is preferred for small sections, whereas post-tensioning is preferred for long span structural elements. Pre-tensioning is developed due to the bonding between concrete and steel, whereas post-tensioning is developed due to bearing. Pre-tensioning is preferred when the structural element is small and easy to handle and transport, whereas post-tensioning is preferred when the structural element is heavy. For example, long span bridges. Pre-tensioning is cheaper, whereas post-tensioning is not that cheaper. It is slightly costlier compared to pre-tensioning. So these are the main differences between pre-tensioning and post-tensioning. Now let's see some of the previous university questions asked from this session. First one, explain pre-tensioning and post-tensioning of concrete with the aid of neat sketch. It was asked for 12 marks during April 2018. In this, you have to define what is pre-tensioning, what is post-tensioning, and explain the three-stage procedure of pre-tensioning and post-tensioning with neat sketch. Now, the second question is, to differentiate between pre-tensioning and post-tensioning, it was asked for 5 marks during December 2019 KTU. In this, you have to define what is pre-tensioning and what is post-tensioning, and you have to write down the differences between pre-tensioning and post-tensioning. That's all for today's class. In the next class, we shall deal with the analysis of pre-stressed beams, mainly rectangular and I sections. Thank you.